Thanks for tuning in, and I'm trying to cover a lot of stuff, and I know that you all are pretty interested in this. You all know, my name is Jarrod Dahl. I'm a turner. I started turning on a pole lathe. I don't know when it was now, 15 years ago, and then slowly moved into electric lathe turning with both Western lathe and Japanese lathe. I studied in Japan a couple different times, and of course, always talking with different people about tools, cutting theory, things like that. So my idea for this is kind of part of the kind of final stages of the book. I'm near complete with Lost Art Press on pole lathe turning, and this is sort of the distillation of years of teaching, writing about how hook tools work, but also gouges and other things work, or at least ideas or perspectives on how to think about those tools. I know some of you have been turning for a while, some quite accomplished. So this might be old information, but maybe it's presented in a different way, or just from a different angle that always helps us to learn from others. So my idea is just to share. A lot of this also has to do with teaching. So having taught for 10 years or more, specifically on the pole lathe, it's a really challenging thing to teach and also do, because hook tools, there's not a lot of solid rules to follow, like gouges and electric lathe turning. There's some rules you could follow that kind of help you to make good cuts without having to fully understand what's going on. So that's kind of what this is about. I have a pole lathe set up, cover a bunch of hook tools, sort of how they cut. I'll be doing a little bit of demonstration, but again, this isn't really a how-to on how to turn. It's about tools, edges, angles, complex shapes, and how to think about how our edges are working, or how our tools are working. So I have the pole lathe. We'll start with that, and then side grain turning, so like a bowl. I have one roughed out. I've done a lot of prep work. And then move to an end grain and talk a little bit about that, the cutting techniques for that. A little bit of hollowing. Again, I'm not going to make finished objects because it's just going to take too much time. And then move downstairs where my Western electric lathe is, demonstrate a little gouge work and talk about those tools, and then move to the Japanese lathe, which is just a unique and something a little bit different that not a lot of people have experience with or know about. So I thought I'd just share a little bit about that. But the commonality between all these tools, which there is this thinking about where that edge meets the wood and those cutting angles, superimposed on the shapes we're making. So that's kind of what we're going to cover. And again, you can raise your hand, and Jasmine will monitor the monitor, and hopefully we can sort that out. We were hoping if there was like 40 people, it might be a little crazy because sometimes people ask the questions all at the same time. That's why we did the hand thing. But if it seems like it's not going to be a problem, people trying to speak over each other with a slight delay and internet and whatever goes on with the waves of the internet, it might be fine just to unmic and say your question, but we'll have to kind of see how it goes. So we'll see. I'm going to move this back so you can see the monitor, Jess.
Okay.
So
where are we?
We're in Ashland, Wisconsin, if you didn't already know. And we're in our classroom at the Woodspirit School of Traditional Craft. This is where we hold different classes. Some pole lathes get set up. We do different basketry and stool making. Dawson Moore will be here this weekend. I think there's still one more spot. And then a bird carving class coming up 2 weeks after. And go to our website, woodspiritschool.com, I believe. Wood School, what is it? School. I should know that, but I don't. Anyway, you all know that. So let's just get into the whole cutting theory thing. So lathes are an access-oriented tool. And what I mean by that is, you know, there's these two centers that support the work, and then that work spins. So everything is spinning on this axis. And depending on how it's driven, with a foot-powered lathe, bungee pole, reciprocating lathe, like a strap lathe. Some of the old lathes were driven that way, like a bow drill, or electric machines, you know, driven. It doesn't matter. It's still always an axis-oriented machine. Probably one of the most important technologies today, the lathe. We still live in the world of the lathe. So everything in our modern times, the machines that make our machines have turned parts. The computers may not have turned bodies, but the parts inside, some of that is turned, or the machines that made those parts have turned parts. So pistons of cars, I mean, everything we know today as technological advancement has to do with lathe technology. So I think they say it's the most important machine tool ever created. So that's, you know, that's kind of the rub. It's likely that the first axis-oriented tool was a drop spindle or a supported spindle for spinning string. You know, and that's a shaft with a weight and it spins. So that's an axis-oriented tool, and those go back, you know, 15, 20, 40,000 years, depending. They find stones with holes in them that the shafts went in. So probably the first one, and then on to crude potter wheels, the axle and wheel, lathes as well, bow drills, hand drills. That was probably the second coming behind the drop spindle. They found teeth that had been, cavities had been filled with some sort of drill. It might have just been a hand drill, or could have been a bow drill. And that was like 8,000 or 9,000 years ago. So that idea of that spinning shaft or the object spinning on those centers or on that axis is ancient. I wonder sometimes where people got inspired by that. And a lot of times that happens through nature. I can just imagine a stick caught in a spider web, slowly spinning, you know, and so for thousands of years, people are pondering these things. And, you know, our ancestors were just as intelligent as we were. They were just limited in technology. So, I don't know, 1,000 nights at a fire, you know, these things come out of our imagination. Anyway. So we have this axis-oriented machine. Our work piece is, the piece we're turning is mounted on those centers. And then again, one of the few machines, if not the only machine, where the user is holding the cutting tool as the wood spins. You know, table saws are the opposite. You're running your wood through the blade. Maybe a router, I guess, is something maybe similar. But very few machines where the user is holding the cutting tool. I guess the router is different that way. So it's quite special in that sense. And then carving, turning is a type of carving. You're reducing, it's a reductive process. So every cut is making this thing that we're turning smaller. And of course, there's no going backward. We're not assembling. You know, chairs are made of reduced parts, but then the object is assembled, where turning generally, or broadly speaking, is a solid object, whether glued up or not, and then reduced to shape. So we have a very finite number of cuts, and then also, just like carving, there's a process in which we reduce the material so we don't work ourselves into corners and things like that. So those of you who've turned, you know these things already or carved. Sometimes you have to think ahead. So I think that's why lathes are fun. Is it poses a specific sort of mindset. Have to kind of think ahead and work ahead a little bit to prep certain materials as you're going. So we have this axis oriented, and how we think about the edge in the wood is related to the surface of the wood that's spinning. So that surface is always changing shape with each cut. And so we're always having to kind of accommodate in our mind, our plan, to adjust the tool as the object is changing shape, as we're making cut. We're constantly reacting and building up new plan. If we're going to be thoughtful about it, that's how I like to look at it. We're like shooting an arrow. We aim, and then we let it go, and that makes the cut. And then when we're done, we have to make another cut. We change, we aim. So as we're cutting through the wood, you know, whether it's an arc or, you know, with a hook tool, to twist or a turn, we're still kind of making a plan on how we're going to go about it. Or at least I would argue that that's what we should be doing so that we're making good cuts. And then to find the right angle is, I think, key. So we have what I call the 20-20 rule. It's not set in stone, but we want to cut the wood on a 20-degree, and I'm starting with full lathe hooks, and then we'll get into Western gouges and electric motor driven machines in a little bit. So this is the precedent as hook tools first. 20-degree angle of cut and 20-degree depth of cut. So we have our axis, you know, our object is here, it's spinning, okay? Never mind what this is or what it's about to be. And then, well, but how do we measure the angle of cut is the trick. And where it's revealed is this arc, what I call the arc, that is a given distance out from the axis in a multitude of planes. So if we're looking straight down the axis, looking this way, you know, this is our bowl we're turning. You know, we might, as a pole lathe turner, our hooks are generally below center. So maybe our tool is on a tool rest, hook is down here. Okay, where is this hook cutting measured on an XY, right? It's so many inches down, so many inches out. And that's going to change all the time. But that's revealed with a tool mark, right? That's the arc that I'm talking about. That's this arc here. And there's many of them, right? It's everywhere. So that arc is 0 on a protractor. So if we put our tool's edge to the wood, doesn't matter where it is on that piece of wood. And a hook tool, of course, has, you know, a complex shape like this. You know, we might be cutting right here one time, and then a couple of minutes later, we might be here, or we might be here. Either way, it's the point that's touching is where I'm talking about, where to measure the angle of cut. So 20 degrees off of that arc. So we can reverse engineer our cuts to find that. This is kind of an over intellectualized way of thinking about hook tools in particular. Some people learn that way, and so when I teach, I teach with that very intellectualized ideas and the perspective. And then there's people who just learn by doing, and that's fine too. They don't need to think about these things. They just get on the lathe and get going. Make it, eventually they're going to have to start thinking about cutting angles. But so that's why I kind of over intellectualize it. When I teach, it's nice to talk about both ways. So the 20 degrees is the skew of the cut. If we put the edge parallel to the arc, that's 0, and then we turn our tool to about 20 degrees. Now we can get away with 30 or maybe even 40, depending on where it is on the object we're turning. But we start with that 20. And then depth of cut. So if we have an object looking down from above, our hook tool is this way. We're going to be cutting in this direction. So we want to point that edge. We want to point the edge of the hook (20 degrees). So you're pointing it into the material. And again, we can go a little deeper, a little shallower, of course. Okay, the other part of this is when we're cutting with a hook or a gouge, there's always 2 parts to the cut. The terms are a little bit sketchy because when we talk about shearing, technically all cutting is shearing because we're shearing the fibers. But if we back out from that macro view and think about just wood fibers in general, or a pair of scissors as shearing, where you're literally shearing it, that's not what we're talking about. We're talking about wood grain. So I use shearing and slicing or peeling and slicing as the 2 kind of terms or concepts. And again, some of this language is hard there's not really the best word for it, but those are the 2 that I've distilled down. I'm gonna get this, just hold on. Any raised hands? I can't draw the 20-degree angle here. Maybe I can try it. Let's see here. The bowl would be this way. Here's the tool marks. So we're going to be draw 1. Our edge tool. Our hook is like this. And it's coming straight out. So that's the 20 degrees in there that I'm talking about. 20 degrees off the arc. 20 degrees off the arc. And that's only where the tool is touching.
Your numbers are really tiny.
Well, they get it. I'm not, yeah. I hope they get it. All right, so just wanted to kind of re-articulate that. Now, what's happening when we look closer, in this situation, we have our wood and we have 2 parts to the cut. The hook is here. This is kind of looking from above. There's this little ledge. Okay. This part of it is going to soon be the shavings on the floor. And what's left is the finished surface of, let's just say, a bowl. So when we're approaching this 20 degree, what we're getting is a cove, and part of the hook is slicing and part of the hook is peeling or shearing. I think peeling maybe is the better word, peeling. So there's always 2 parts to a cut. And we're gonna exploit that depending on what it is we're doing. If we're working on the rim of a bowl or the rim of an end grain cup or the bottom of the base, working through the body of different objects, there's different perspectives because of the shape of the thing we're making. So we have to kind of think about how that cove is in relation to the grain of the object we're turning as well. The beauty of the lathe is that we don't have to worry about grain as much as, let's just say, carving, because we can cut into the grain a little bit, especially with side grain bowls. There's always a couple different two sections that we always are cutting into the fibers. But broadly speaking, we have to think about the fibers and how they interrelate with the shape that we're making. And I'll just throw out this, like when we say grain as woodworkers, it's one of the most vague things for a beginner or someone with no experience to understand. What is grain? Grain is really meaningless until you think about the object or the shape of the object and how it relates to the fibers of the wood. That's what grain is. So I start to use that more complicated explanation, and it helps people to understand. You want to pet the cat from head to tail, and those fibers are along the back of the cat pointing a certain direction. So that's how it's another way of thinking about it. So when we're turning, of course, we have to consider that. Moving a side grain bowl or moving from rim to, the other way. Moving from base to rim. On the inside, it's the opposite. End grain cups are a little different. But some of this relates to hook design and how to make tools cut effectively. So that's why I'm introducing these main concepts, because when we get into the hooks, if we have an understanding of this, then we'll understand how these hooks work or how we need to design them. Or if you're an electric lathe gouge user, the different grinds of bowl gouges, how skews work, all relate to all of this as well. And then, of course, the Japanese hooks, they're just a different shape, but it's still the same cutting theory. So I'm going to move to the lathe. Questions?
I don't see any questions. Is the video quality okay, everybody? Yeah, okay, cool.
Okay. So you might have to come a little closer.
Yep. Just do this.
We just have to keep an eye on the man.
Okay.
And you can set that up here if you want, Jazz.
Well,
Okay.
okay.
Okay, so on the bowl, what I have here is a roughed out bowl. Side grain, it's actually vertical, not vertical grain, but like quarter sawn. But anyway, the main fibers are running this way, not this way. And I rough shaped it, and you can see those tool marks. I hope you can see them. I mean, if everybody's a turner here, you know what I'm talking about, right? We have all these tool marks. So that's 0. So, and then we have this surface, and you can see it, in the silhouette. So I'm going to take a hook, and let's just look at the hook for a minute. I'm going to move it right there so there's a backdrop. So this is kind of a standard pole lathe bowl turning hook, kind of a medium size, good for everything. And one of the main key design features of bowl turning hooks for pole lathes, I would argue for any lathe, is a little bit of a back bend here. It helps to get the tool away from the wood that might, you can only see it by looking straight on. So, back bend. Not too much. Now, the edge goes from where my fingernail is all the way up around this scrolled tip. And I'm also, after years of making hooks, I'm kind of settling in on a hook that isn't have a lot of taper before it's scrolled. The taper, for those that are turners, Derek, Eric, some of the others, we can adjust by just moving our hook pivot point. So tapered hooks they're not really needed. And I would argue that they're less versatile actually. So I'm not doing much taper. So when we're talking about the edge from my fingernail all the way up to the tip, and then as a pole lathe turner, we need to, so now you can maybe back up Jazz. I'm going to show the whole.
Okay, I'm going to check out the comments as well here.
So bear with Jasmine, she's going to kind of look at the screen just to make sure we don't miss any comments.
Okay, Kalia's asking about using hooks with a powered lathe. So we're going to get to that later on in the talk.
Yeah. Hi, Kalia. Yeah, we're going to go downstairs and talk a little bit about that. Gouges work pretty good already, but anyway. So we have, as pole lathe turners versus electric lathe turners, pole lathe turners are bound to the pedal. We can't walk around, we can't move very much. We're stuck pumping on our pedal. So there's very few, we have to stand in this one position all the time. And that's kind of why hooks are the way they are. So when we're setting up to make a cut, all the tools we use, gouges and hooks, they all, to some degree, pivot. Hook tools have mostly pivot. Gouges, there can be some sliding, but you're also pivoting on the bevel. And I'll get downstairs and talk about that. So we control depth of cut by how we pivot. We're not pushing at all. There's no sliding because that's out of control. We can't control that cut. So it's always pivots. So we're pivoting through the cut as the wood is spinning, and we change our pivot points constantly. And when we're doing that, we're trying to keep those sweet cutting angles and depth of cut. So we have pivot. We also have a wide range of adjustments. We can go up and down, and go across, right and left. And we can also turn the hook and twist it. Because this lathe isn't working very fast. It's, maybe 100, 150 RPMs. And not a lot of power. Like if we dig in too deep, we just stop. In a sense, we're cyborgs with the pole lathes because we're integral into the machine itself. We're controlling the power with our minds. Cyborgs. It's a weird tangent, but it's true. So we have all these different ranges of motion, and that's what's tricky about finding a good cut. We reverse engineer that kind of 20/20 idea, and we're going to put that tool wherever we need to get 20 degrees depth of cut by changing the pivot position. So I'm pointing the hook into the wood, and then I'm twisting to skew that arc, the zero or the safe position. So if you want to kind of zoom in, Jess, here. So right now,
That's good.
I'm pointing the tool about 20 degrees into the wood. It's hard to see unless Jasmine shoots from above.
Okay.
Yeah, that's good. You can swing it back down. 20 degrees into the wood. And then right now it's at 0. It's parallel to one of the arcs. So I'm going to turn it to about 20. And that's going to be where the sweet cut starts. So that's 20. With hook tools, we might have to be on the rim of our bowl. We might have to be way below center to still get that 20. Move your camera to the right. Yeah. To get the 20. Okay. I'm using a different part of the hook and I'm measuring it just where it touches. And that's along this curved surface. Now we're working on the base or the rim. The fibers are parallel to the surface. So we can make that 20 cut in 2 different ways, but we can also just do a pure peel cut only because the fibers are parallel to the surface. This is one of the few exceptions. So a 20 cut on the base would be something like this. And I would turn it into the wood. I'll demonstrate these cuts in a minute. Or if I had the tool rest in the right position, this is also, if you look from above, you don't have to get it, Jess. Look from above, it's 20 degrees, and then the arc or 0 is there. I'm going to go 20. That's where I would start making my cut. And then I would be pivoting out. On a pole lathe, this is a really hard one because my tool, if you want to back out a minute, I can't control my tool because it's way out here. So when I'm turning, I tend to do my 20 this way, pivoting up. But then there's the shear, because the fibers are parallel, we don't have to worry about the arc at all. We're going to just do depth of cut, and we're going to make that maybe 40, 35, 40 degrees. And then we can just pivot up and down and just shear. And it's only because the fibers are parallel to the surface. Once we get a curved shape, we have to go back into what we did on the outside. Now, this directly relates to how the wings of gouges work on electric lathes for the same type of cut. And of course, the rim as well. Now, something popped into my head. That was really important, but it just totally gone.
Kali is asking about if the same rules apply for a ring tool.
Ring tools are the same as a hook. They just go completely around, so you can work them in reverse by flipping them upside down. Whereas a pole lathe hook, we'd have to make a different one that's sharpened on a different side to do the same thing if you're going to work in reverse. I'll show that on the electric lathes downstairs. I have different hooks that I've made for that. But the ring tool is the same. It's the same cutting theory for all of these tools. The last part of this, I guess I'll make the difference because I know there's some electric lathe turners or gouge users. The edge geometry, the thickness of the blade and the edge angle, the edge geometry is important, especially when we get on to more powerful machines. Pole lathes, I remember what I was going to say. Pole lathes work at such a slow speed that we need to bring the edge geometry to a very fine cutting angle. And never mind the slice shear part, overall, we're still slicing. And we need that thin edge to make slices on the surface because we just don't have the power if the edge was more obtuse. So when we get into electric lathes, you can get into a more obtuse edge angle. And then the shearing action is really beneficial because of that thicker or that more obtuse edge angle. But pole lathes, we just can't deal with it because of the power. Now, one of the last things I wanted to bring up was speeds. And this is just stuff to think about. And I'm just trying to articulate my thoughts in different forms. So, you know, this is always like jazz for me. I never really rehearse this and just sort of make it up as I go. So I'm going to just throw in speeds for a minute for you pole lathe turners, but then a little bit for electric lathes too. We measure speed on a pole lathe in a little bit different way than would be on electric lathes. RPMs are kind of a useless way of measuring speed. Rotations per minute, but we're pumping, we're creating that. So if I pump once per second, then it's 60 RPMs. That's pretty typical of what pole lathes, maybe a little bit faster than that. That's why I say it's maybe about 100, 125 RPMs. But that doesn't talk about the surface area speed. So when you get into machining metal, machinists use feet per second as a way of measuring speed. So RPMs could be a constant. My mandrel, for those who don't know, there's this shaft mounted to a pole lathe. We always need a mandrel to wrap our drive strap on. Electric lathes, their mandrel is actually the spindle and it's deep inside. So there's different types of lathe designs, but our mandrel is the spindle or drive shaft, which is driven by the power. We need to have that attached. So this diameter here, feet per second, or RPMs, the RPMs of this shaft and this bolt is the same. But if we measure in feet per second, this bowl is going to be going at a faster rate, just measured in a different way. So this is going faster than this, measured by feet per second. And that's important to understand this pole lathe turners, the relationship between the two. This is a type of gearing that we can exploit. So the larger the mandrel, or the more equal the mandrel is to the bowl, you're going to have a lot of torque. You're going to be able to power through, but the differential speeds are going to be similar, and it's going to be kind of turning kind of slowly in that regard. Whereas you get a smaller mandrel and the object turn, then you're going to get a lot of speed differential, but you're not going to have a lot of torque. And your end of drive strap will burn or slip, especially when you put a tool to the surface and you take a heavier cut. You're just not going to have the torque. So there's a balance between the two. I like to think of it as a third to a quarter, 1:4, 1:3 for side grain, mandrel to bowl diameters. End grain is a little different. I like it more like a quarter, 1:4. Plates, again, plates, the grain orientation is more like a shear at the bottom, the bowl, so we can get away with less torque and more speed differential because of the way the fibers are. So I just wanted to throw that also in there. It does play out when we use electric lathes to what speed should we be turning, and the difference of rates of speed when you're making your cut from the outside, the rim of the inside of the bowl down to the center of the bowl. You're dealing with different speeds as your tool gets to the center. And that affects the way the tool's cut. Anyway, so I'm going to demonstrate a hook tool in use and just show that 20-20 degree cut on the bowl and on the base. Maybe I'll flip it over into the rim, and then I'll do a little hollowing because I want to talk about thinking about how to hollow on a pole lathe. So
Where do you want me?
you come closer, I think.
Okay.
And I'm normally when I'm turning, I have a nice, not a super firm grip, but a grip on the handle. But because of the camera and the demonstration, a lot of times I'll take and I'll move my hand away so that you can see. This is not a proper technique, having my left hand away. But I just want to make sure that everybody can see it. One of the things that I want to also point out is that if you get your cut right with pole lathes, the resistance or the force that's spinning, it pushes the tool down into the tool rest, and then you don't have to hold very tight. So a lot of times after you do your initial roughing, you really only have to put a couple fingers on your tool and just push down slightly. You don't have to have this death grip once you understand how the tool works. So if there's beginners out there, I hope that digging deeper into the cut, understanding the cut, will help you to not have to hold so tight. So I've already roughed this out. There's 0. It's still pointing into the wood a little bit, but it's 0. So I can make this thing spin, and there really isn't any cutting happening. If I pivot, I could cut a little bit, but it's going to be a really thin cut because the edge is parallel to the arc. But as I open it up or turn to 20 degrees away from 0, now I'm getting a bigger shaving. You know, and as I continue to move that cutting angle to 90, you know, that's going to grab. It just stuck in that end grain. You can't go 90. Maybe 45 is max. But I would argue that that's not super efficient. You should be thinking about the ledge and not the cutting surface. So what I mean by that, so we have this ledge here. So the tool, the cutting angle is what's slicing on the surface of the wood. And also, this other part of the hook, this lower part, is what's peeling the fibers away on the ledge. And remember, this ledge, the fibers are the same cut as the bottom of the bowl. They're parallel. So when we're doing this shear cut, I don't have to worry about 20-degree cutting angle. I just have to shear or peel, you know, at a 30, 35 degree to surface. Because the fibers are parallel. There's always a little fuzz that depends on the species. And I can clean that up with a pure 20/20 cut. But what I want to talk about is that ledge. That ledge cut, whoop, is the same shear as what's happening on this flat. And then your twist, your cutting angle is how the surface is going to be. It's the slice. So the more open or the more away from 0, you're going to get less effective slices, torn fibers. And the more it's close to 0, the smoother and smaller the cuts are going to be, and more finished surface. And by doing that, you can think about the shear part of the cut more than the surface. So if I drop this cutting angle down to, let's say 10 degrees, which it is right now, there's a slight taper to the hook. So the 10 degrees is kind of built in. I'm making a real fine cuts by lowering the cutting angle. And I'm still shearing on the ledge or the waste material. But if I drop this, if I bring this hook cutting angle down to 0, then the part that's on the shear is at a 90-degree. It's the same as this. It's just gonna scrape. So there's limits to a hook, a thin-edged hook. There's a balance between cutting angle and depth of cut. Oh, not depth of cut, that what's going on that shear part of the cove. When you're talking bowl gouges now, that thicker edge geometry allows you to make a better shear or a better peel at a lower cutting angle than a hook. And I would argue that bowl gouges make a better finish all around with wood because of it. But we can't use bowl gouges on pole lathes because the tool rest and being bound to the pedal doesn't work. And that thick edge geometry we need too much power to power through. So nice slice. You're always thinking about that ledge too. You know, one could design a hook that's maybe really fine on the tip and then thicker and a more sharp angle on the underside or more obtuse. And then you'd get a better shear. But that'd be a really complicated tool to make and to maintain, having changing thickness, changing edge geometry from base to tip. It might be possible. So that's something to think about. Now, when I think about the base, I can do a slice. This is a 20-degree cut. So it's the same cut as on this outside surface. I'm slicing on the finished surface and I'm shearing on the ledge or peeling. But this time the end grain is exposed to the tip part. And then that leaves a lot of fuzz because it's almost pure end grain. But then if you want to clean up that nub, then you think about that surface, a 20-20 on the nub or the button. We're thinking about slicing on the surface. There we go. Now we've got a nice slice on the nub. And then there's this bottom material that's in the way. I can shear. Or peel. Now I'm going to work on the nub. That slice has to be along the surface, the finished surface. You're always cutting on a cove, so understanding where the slice and where the peel is important. Again, I can also do a slice on the finished surface this way. But the other part of the cut, the grain orientation is making it into a pure end grain situation. So the peeling or the shearing doesn't really happen very well, only because the grain's pointing right into that part of the cove. So there's another hook here. So for pole lathe turners, well, anybody who's interested in hooks, we can make these really versatile tools. Let me just grab some. So when you're thinking about designing your hooks, thinking about 20-degree cutting theory, you're considering one part of the hook that's going to be peeling and then the other part of the hook that's going to be slicing. So an untapered hook is going to act a little different than one that is tapered. The taper of the tip is the slicing part. And so you're going to have more slice, an angle, let's see, an increased cutting angle on a tapered hook than you would on an untapered hook. So you're going to, but then when you think about the cove part, the peeling part, you want a nice shear angle and not a scrape. So you're going to end up turning your hook a little bit to get a shear, and because the tool is tapered, you're going to have an ever increased cutting angle. It's getting closer to 90. So an untapered hook will allow you to shear more effectively and keep that cutting angle closer to 20 degrees. And so you're going to get a better surface. Remember, the sliced part is the finished surface. So I'm going to demonstrate this hook compared to the other one.
Closer?
Yeah. So what we're talking about, I'm going to try to make a bigger cut so people can see. All right, so finished surface is the bowl. You can see right now, possibly, let's come to your left a little bit. It's 20 degrees cutting angle, but because it's not tapered, the lower part of the hook that's doing the peeling is at like a 20, 25, 30, which we demonstrated here as the sweet angle, right? That's peeling away those fibers from the bottom. So we think about the bottom and that part of the ledge as the same. We're going to get a better slice and a better shear than a tapered hook. I'll use Mary's. So I don't know, it's hard to see, but if it's really tapered on the tip, you hold that shear to the sweet 30, now you have almost a 45-degree slice. And to make the slice less, to get a better surface cut, now you're scraping on the shear part of the cove for the cut. It's almost at a 90. So an untapered tool is more versatile. It puts us in a better position to cut and peel. So let me get the bowl flipped. I hope people get that, especially Lathe turners. Not sure where the tapered hooks came in and why. It might have been just from examining old hooks that were over sharpened and then they were duplicated. Maybe Robin did that. But we need a tapered hook. So I'm just going to peel away a little bit. Here, peel. So as long as I keep that surface parallel to the fibers, this pure peel cut will work. But as soon as I start to make it hollow, then I need to switch my perspective and approach and do a slice on the surface, the finished surface, and then of course the cove part of the cut is the peeling, shearing part. So we're always understanding the slice is on the finished surface or would be finished surface. except for, again, the parallel situation. Rim. So pole lathe turners, we have this mandrel in the way. Yep.
Brian asked if the ring tool is basically like an untapered hook.
Yes. The beauty of the ring tool, though, also is that one is beveled and one isn't. So, and again, ring tools are better for end grain, mostly they're for end grain, but you could use them on side grain too. There's a turner, Wolf Jansson, he's in Sweden, I'll visit him next month. He uses like carpet gouges on the outsides of his turning wood and stuff too, just to point out that if you have a thin edge, like a hook, you can use all kinds of things. If you know the cutting theory. So yeah, ring tools, it's all the same as mostly like a pole lathe hook. One of the trouble with the earlier ring tools was that they were so small that they get clogged with shavings. But I see Hans Carlson now is making a little bit bigger hook, ring tool, the replaceable head. I'm hoping to just try it out and see, instead of having to hammer out my own, buying a ring tool. Oh, a ring tool might be cool, but I have a feeling that they're not as versatile as some of the gouges that I use for deep hollow forms for end grain. But yeah, same theories on all of this. All right, so I'm going to hollow. What I was saying with pole lathes is we have this mandrel in the way. Unlike electric lathes where you could just grab it with a chuck, we have to work around the mandrel. It poses a serious challenge.
Charles Brosseau, is the first peeling cut being done now to true the surface of the bowl better done with the untapered hook?
It doesn't matter because you're only shearing or peeling. The fibers are parallel. So yes, I'm just truing it up. It doesn't matter because you're using the lower part of the hook. And again, with pole lathe turners, we can just change our pivot point. So it doesn't matter if it's tapered or not. But if you're going to want just one hook, an untapered one, as I've demonstrated, is going to be better. The taper has nothing to do with the truing of the surface of a bowl, if that makes sense. It's irrelevant. So, mandrel's in the way. We have to hollow the bowl and also cut on the mandrel side. So there's a bowl side, and then there's the mandrel side. So in fact, we're basically cutting a nest. We're not going to save the core, but it's the same thing. And what we know about turning and wood grain, side grain, when we're working on the outside of a bowl, we carve from base to rim so that we're petting the cat head to tail with our tools and the fibers. If we imagine a finished bowl, or you don't have to imagine, it's right here. The fibers intersect this surface. You want to carve or turn, cut from rim to base on the finish side, right? So we're going to go from rim to base. But we have all this wood in the way. We can't do that. So we're essentially going to be carving two bowls. One of them we're going to be carving normal from rim to base. And then if we think about the core, we're also going to be carving the outside of another bowl backward from rim to base, going into the fibers. So understanding wood grain, understanding that surface relationship with the grain, and then understanding the cutting angle and the depth of cut are what's going to help us to carve that inner bowl or the core backward. And I tend to like a smaller hook because it has just less resistance because it's taking a smaller cut. So to get started, and again, this is really specific for pole lathe turners. And if you're teaching, you know, thinking about how to describe this with helping people along the way with this is really a challenge. You okay, Jess?
You're getting tired.
Oh, really? Why don't you rest your arms on this?
Yeah. What? Yeah.
So, I mean, this is the last, and then we go downstairs.
Okay.
So, we have to slice on the surface of the inner bowl, but then we're also then scraping and grabbing or cutting on that core because of the way the edge tool is interacting with the fiber. Same as the button when I turn the button on the other side. It's pure end grain with the tip part of the hook. We have to get into the wood. So we favor the core side, which is, you know, thinking about 20 degrees depth of cut, or 20 degrees angle of cut. Depth of cut's a little hard to measure. So it's kind of that shear cut. So it's kind of a combination of perspectives for the core side. So I'm gonna slice along the core and I'm gonna scrape or peel at the bottom of the cut to go in a little deeper. Scrape, or shear. But I got a little hole. Now I can drop my tool below center. That's about 20 degrees to the cut or to the arc. And depth of cut for pole lathes here is, turners is to turn the hook. Depth of cut, so that would be like 90. That's 0. So 20. Slice on the surface. Now, if you look at that core side, that's going to be a pure 90-degree cut. It's going to be a grab. So I have to stop short of the core. And then when I want to go deeper, I'm going to go deeper on a core style cut. So it's just scraping on the bottom, not grabbing, not catching. Slice on the core. Scrape. Now slice on the bowl. Slice on the core. Going deeper, scrape. And then I'm just going to go back and forth. So let me just turn to just a few minutes. Take a couple slice cuts, couple core cuts. Anything at the bottom. So you might want to zoom in on that too. So I'll just show a close-up slicing on the core. So that's 20 degrees, 30 degrees angle of cut. Again, I have a tapered hook. It's not in my favor. The more I turn the hook, the more it goes to 90. So an untapered hook on the core is going to be beneficial. And I think I gave it all away, but I have a hook that actually flares out on the tip, putting it into a better cutting position for the core. So slice. Remember, there's always a ledge too. Like, think about it. Oop. Oop. And then slice on the bowl. Okay, that's the standard stuff. Now for pole lathe turners, we can plunge in to the core. So there's these reverse grind hooks. They have a slight bent shaft. The edge is on the opposite side of the other hooks. So if you come in close, Chaz, why these bent shaft hooks work great on the core is now look at the cutting angle. It's closer to 20. They act differently. They act actually the opposite in a way of the regular hook. So this will this will slice on the core easier using the base of the scrolled hook than the tip of the scrolled hook in the other case. But this tool is a training wheel that you'll never want to take off. You want to learn to core. You shouldn't use a reverse grind hook because it won't teach you how to cut on the core with the tip. Because when you nest, you need to be able to make two bowls out of this, and the core is a bowl. You need to use the tip of your hook, not the base. So this is okay to start, but it's just right. And I can push it into the end grain. I'm just pushing it in. It doesn't really grab. So if I switch to, you can stay there. Switch to a nesting hook. I'm not going to nest for you guys, but I'll show you. Small nesting hook. Very tip. The important part of nesting hooks is that the scroll is closed or it reaches around, because I'm going to be using the very tip to cut in on this core. And you can practice tipping your hook all the way down. So again, it's a cutting 20 degrees. Right now, 20 degrees cutting angle, depth of cut. It's hard to see, but it's under the hook like this. That's like 25. And I'm going to be pivoting this way. So that's how I'm measuring it. And then I can actually cut into the end grain. So essentially, I'm making a new surface that's going on an angle, and I'm slicing along that surface, and I'm shearing on the waste material. The same as the outside of the bowl, the same as the inside of the bowl. It's the same cut. I'm just going at it from a different angle. See that? Slicing on the core. Shearing on the waste material right there. It's the same cut as we've been doing. I'm going to grab a little bit more. So that's how you think about nesting. You're going to be cutting, slicing a little bit, and then shearing a little bit of peeling, slicing, shearing. Now imagine doing that inside, following the curve. It's that simple. Okay. So, questions? This will be good to watch over and over again.
You go downstairs then?
I was just gonna talk about end grain real quick on the lid.
Oh.
So, roughed out cup. I use my electric blade to rough it out. I left a tenon on it, so I can use it with four-jot chuck. But if it was pole lathe turned, it may not have this, but there's the center mark. your mandrel. So work on the outside. And for those that are teaching pro lathe turning, I like to have students turn mandrels first. And it gets people to understand how the hooks work with just a simple form. You can get the 20-degree cut. You can get the depth of cut really easy. And then they get an understanding of it before they move on to more complex shape and hollowing. So with end grain, the fibers are running long ways. So it's a whole different perspective than side grain turning. What we're going to be doing is slicing along the surface. A shear, like we did before, would be a little bit lower, getting that 20 degrees, like a pencil sharpener. Or for those who are electric lathe turners, like your roughing gouge, same thing. Except the edge geometry of this is really skinny. It doesn't act the same way. So we have to exploit a slice, mostly with hooks on end grain. So depth of cut is lower. Cutting angle can be adjusted, but depth of cut has to be less. And we just work across the surface. So with end grain on pull lathes, I adjust depth of cut by raising and lowering the tool. That's changing, that's changing the depth of cut. And then twisting, of course, is what does the cutting angle. So if I want to get a little deeper depth of cut, I drop it down. So you get the idea. Yeah, thinking about switching perspectives now. Where's the slice on this part? It's not going to be like the bowl, the side grain bowl. You're going to have to slice along the surface like this. Being mindful of that tenon, I'm going to be at a really 90-degree shear peel, which will grab the tool and pull it down. So I have to bring up the depth of cut a little bit so it slices on that. Not slices, but shears at a less angle on that tenon. But it still wants to grab. So instead of trying to get a sweet slice, a lot of times I'll favor just a scrape. It's actually a little bit less grabby. So I'm just scraping. That's all going to be wasted away anyway. I'm kind of skipping over this a little bit. And then for hollowing, for pull lathe, it's kind of the worst. It's probably what caused me to have an occupational injury relating to turning. Some of you know I used to turn lots of cups, and I used to turn lots of cups with handles. And it was the handled cup. So the beauty of the pull lathe is that it reciprocates. And so you can turn objects with an integral handle. This is one piece of wood. I've axed this out a little bit, left a projection, mounted it similar to this cup. And then with controlled pedaling, you can turn up to that handle. Bang, bang, bang. You gotta flip it around. Bang, bang, bang. Go back and forth. And that real controlled pedaling, standing on one leg, really putting a lot of force on the standing leg is what gave me a lot of pinched nerves and stuff in my leg, which caused me to not turn on the pull lathe much anymore. And also move into Japanese style turning, which was a cool effect. besides the pain I get when I turn on the pulleys. So hollowing is brutal. I tell people not to try to do end grain hollowing on pulleys until you can cut nests, and without major catches, like 50 of them. Like you have to have a lot of tool control because you're pushing this tool straight into end grain. And if you add too much pressure, it just catches. And if you're hollowing something deep, there's just a little slop and you get halfway and then you make a catch and then you're gonna break your mandrel connection or kink it and then you can't finish. So you just save yourself a lot of hassle and heartache and work your way up to it. So with end grain hollowing on pole lathe, we just have to have a small hook that has a little bit of a taper to it and we just plunge it into the end grain. And then when we're doing the finish work, we have this tool. Oop. Some people in the pole lathe, Sharif kind of renamed this the politician hook. But it's really a riff off of, you hold still, Jazz.
Oh, okay. The focus is funny. Okay.
It's really a riff off of electric lathe turner named Andre Martel. He makes something similar, but it's small and it goes into a shaft. It gets screwed in, and I use that. Robin Wood told me to check it out. I was starting to get into end grain when no one else was really. He'd fooled around with it a little bit. Martel's hook didn't quite work right. The geometry wasn't set up for the low torque, low speed of pole lathe. So I proceeded to drop the angle a little bit and then add a little back bend, which you can see there. And then went on to show you all, share you with all you guys. So that's what you use to make your smoothing cuts. So at the bottom of the trough, you run your finishing hook in, and then you're slicing along the surface again, the same as we always have been doing. 20, 25 degrees. So plunging, I'm just going to show this real quick.
Where should I be?
This is a little closer so people can see.
On that side?
They got to see the hook. Yeah, that's good. You can look at, oh, you can see. It looks like there's a question. We'll get to your question in a minute, Kalia. Let me just demonstrate this because Jasmine's all set up. So I'm just plunging this in. It sounds as brutal as it really is. And you plunge that in, and then you take your slicing finishing hook, you put that into the slot, and I can demonstrate it here. And then you're slicing on the way out. That has to do with the fibers. Think about the fibers and the direction of the fibers in relation to the shape of the object. So we're petting the cat from head to tail. And then at the very end, to cut the mandrel core off, I have this, trying to get it background.
Let me get a little closer to.
This tool comes in at the bottom of the cup and then cuts the core off, basically with a pure shear cut. So I hope this helps you guys think about things a little bit. Like I'm always thinking about where's the shear, where's the slice, where's the grain orientation, to get better cuts. So we're gonna move down to the electric lathes, and I'm just gonna talk about gouges and Japanese hook tools. Probably another 15, 20 minutes maybe. Jasmine's arms can hold it. And we'll field some questions. Probably, I would guess a half an hour by the time we're done. But all this relates to gouges too. And I guess for me, I want to say that I think I've had an advantage starting with pole lathe hooks because I've really had to understand how they're working, how they're cutting. There's no rules, like a bowl gouge, if you keep your bowl gouge level and you use one wing and the tip a little bit, you're gonna be able to make a bowl without much problems. There's some solid rules that you just follow and it works. With hooks, as I've kind of demonstrated, they're so variable and a lot of times we're below center. There are no real rules except for 20-degree angle of cut, 20-degree depth of cut. We have to we're forced to reverse engineer every tool we make and use on every shape. Or I would say we should be trying to understand and reverse engineer. So starting with hooks, it's been really good for me as I moved into electric lathe and gouges, or teaching people who use gouges and then they try hooks out and sometimes they really struggle to try to get them to work because they want to fall on those hard, fast rules of keeping your tool level, but it doesn't work that way. So with those experiences that I've reflected, it's like, yeah, I've had some interesting experiences that set me up to understand how gouges work differently or how they work. And I would argue in a little bit more nuanced ways than some. I'm not saying that I know a lot, but the hook tool perspective really helped me to understand gouges. So I'm going to ask, I would like to hear quickly about the scraper for bowl bottoms, please.
Bottoms are bowl feet, the foot of the bowls.
I don't use a scraper on the bowl bottoms. I use a hook. So Charles, I'm not sure, you can unmic and ask if you want or write if you feel comfortable writing, but I don't know if I understand what you're asking.
The surface, the point where the foot of the ball meets the outside of the ball, the corner, if you wish. I always have difficulty getting a clean, like in the very corner, I have always fibers left out there, and I would like to know how you deal with it.
Okay. A really small hook for starters. I do use a scraper too, but wasn't sure. Thanks for clarifying. I would say that some of this has to do with really getting an in-depth understanding of where the slice and where the shear is. And so if you have a really small hook, I would even say smaller than this, Joe, you have to come up close. I don't know, my thumb is an inch wide, if you want to scale it.
It's not focusing very well there.
This hook is less than a half an inch. I would say even smaller. But I think the key for that cut would be, again, an untapered hook. So you want to come close on this. Dropping below center, I can, no.
I'm just showing the
Yeah,
angle.
okay.
Okay.
Yeah, there it is. Dropping below center, I can slice along that foot and scrape on the bottom of the bowl a little bit. Turning the hook, I'm going to over exaggerate. Turning the hook makes more slice, but also a better shear on the bottom of the bowl. So you have to find the balance, and you can see a tapered hook isn't necessarily helping with the shear slice combination here. So you have to establish your foot. And again, you could hear the scraping, scraping on the bowl part. Then swing around. You could stay there, Jess. Swing around and then try to get your small hook to slice down. You know, one more thing, Jess, you can stay. If you have a reverse, this is probably the best application for the reverse grind hook, especially a small one. You can see how this one actually slices now on the foot and sets up for a better shear or peel on the bowl part. I can't make the cut because Jasmine and I are doing like a twister thing back here, but so you're going to get a better shearing on the bowl there, which will make a cleaner cut. As soon as you get out enough, then you get back over to a slice. So with a hook, you have to have that small hook or that bent shaft. Later on, I got into using a little scraper, but it's only for making like a nice little line. It doesn't make great cuts. So you could drop it below center and pivot it up right in that spot. But the scraper with greenwood and the low speeds, it's more fuzzy than a hook. So I don't advocate for this. I only use this for cutting the grooves in for locking in boxes and things like that. Get the right small hook made and you'll be set. Squarish corners rather than smooth curves. Yeah, Kalia, the Japanese hooks are more like that. There's still always a slight radius to it. Should we go downstairs?
Yep, so you're gonna hold this?
Okay, I'm gonna take the camera.
Let's check what the percentage is on.
I can't see it. Okay, bear with me. I'm gonna walk downstairs. Grab the, oh, you got the charger. Try not to walk too fast here. That's the door outside. So we have Japanese lathe. I'll talk about that in a minute or two. I'm going to go over to the other lathe, the Western electric lathe. So, I bought this Harvey a couple years ago. I like it. It's a little underpowered for how I'm turning or how fast I want to turn, but you can move over here. Okay, so I'm just going to demonstrate some cuts on this lathe as a way of sort of tying the similarities of thinking of cutting angle, shearing, slicing, or peeling, slicing on gouges. Again, I'm not posing to be an expert with gouges. I'm still learning a lot about them. But with this pole lathe hook tool perspective, I feel like I'm able to make a lot of cuts with a pretty limited number of gouges. And then the trick would be maybe the bottom of the bowl. I'm still having hard times with. But also we're gonna do end grain hooks, and I'll talk about those and demonstrate those. The beauty of this, Jasmine, and everybody else, is this is really fast compared to Lathe Turning, so you don't have to hold the camera much longer.
it's like that up ahead thing where you're like working up, your arms just ache and ache. You wouldn't think that standing like this with a phone for an hour would be impossible. So I roughed out this, I mostly turn green, but every once in a while I get into, well, I should say that I turn green bowls, but I turn dry cups most of the time on electric lathes. With pole lathes, it was always green. And I've had various assistants help me out. So we did make some, what we call twice turn bowl blanks, just to get through some of the sweet material that I had that I didn't want to throw away. And I couldn't get to it in time before it would start to spalt or check or rot. So I turned it into blanks, or heated anyway, my system. And he learned some things by doing so. So this is a dry blank. And of course it warps. So I have a tenon on the end to put it in my 4-jaw chuck. And what I did was I rough turned the rim so it's true again. And then I just have this plate that I'm gonna push it in on the with the tailstock, and then I'm gonna make just a few light passes, and then I'll chuck it up, and I'm gonna make some cuts on the inside. So
I'm gonna check the screen. Maybe scroll up a little bit. See. Scroll up on the chat and see if there's any other questions.
No.
maybe you should be here for now, maybe.
So this, if we think about this gouge as, you stay still, Jazz, let me get it to focus. Will it focus?
I think put your hand
Oh, wait,
behind
no,
it.
wait, there it is. Okay. So this is a bowl gouge, a deep flute. That's the shape of the inner part. And if you hold still, if you move, then I'm gonna lose my focus. It sees my finger, and then, so anyway, so there's the wings and then the tip, and this is what they call a 40-40 grind. So it's 40 degrees cutting angle and 40-degree wing. I like it, and without getting into the weeds, everybody has opinions about gouges and what can and can't do and which ones are best and not. I'd rather not get into it. I like this. I use it a lot. I don't have any problems with it. So that's that. Other people like other grinds, and that's cool, whatever works. But the cutting theory stuff that we've been talking about it's still the same. Except for with gouges, we have a thickness or the edge geometry itself, which is a little bit more, it's a little different, right? Those hooks are really thin, almost like a razor blade cross section, or a sloyd knife or a carving knife, if you're familiar, where these are a little bit thicker. And I forget exactly, but you know, that edge geometry, looking down there, you know, I don't know. It's quite blunt compared to a hook. And what that does, especially on the wings, it's allowing for a shear cut. When we're twisting the tool, it's allowing for that shear to happen. That's the waste material. It's the same as the hook, the peeling or the shearing. And so that bevel's on the outside. And so by twisting it and turning it, we can change that shear relationship. And then the slicing is happening on just the very tip of the gouge and just a little to the opposite side of what's being used as a shear, which wing is being used as a shear. So it's the same thing as the hook. It's just a different shape. And again, the shaft is long. And so where pole lathe turners have to pivot to make their hooks work. You know, pole lathe has to pivot, gouge is pushing. Now, pole lathes hooks tend to have no bevels on the underside, or I would say they shouldn't. The bevels on the inside, if there even is one, it's mostly a wedge shape, or even convex like a felling axe. And the depth of cut, you know, there's no riding of bevels, so I'm kind of switching to electric lathe terminology now. Electric lathe turners use the bevel to control depth of cut, where pole lathe turners use the pivot point to set the depth of cut. And then we're pivoting through the wood. So pole lathe turners are kind of going in and out of the wood, or at least partial the way out, and then resetting a pivot, turning, pivot, resetting, pivot, 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 without losing the ledge. Where gouges, we're sliding and sliding along, or pushing or pulling. And because we're not bound to the pedal anymore, it's really easy to make those motions. And we can set up a tool rest in a way that will help us to slice, shear, make those long flowing cuts. But also with gouges, we have bevels. These, you know, they're thicker, and that bevel then allows us to change depth of cut. There's a little twisting too going on if we're changing the shear or the depth of cut when we're using the wing, the shear angle, but that's still the same thing. There's some twisting, but overall, where we talk about riding bevels a lot. If your bevel isn't engaged, just your tip is, you end up getting a lot of chatter, or it's really hard to control your cut because you can't make these fluid motions. So you end up getting extreme tool marks at the bottom of your bowl and things like that because you're not having your bevel engaged. You're relying on your pivot point, which for gouges is actually not so good. So there's some differences between the two tools in that regard, but the geometry is still the same. So, yes, I can't get a full nice cut with this gouge in the base because the tailstock is being pushed. I didn't start with a fresh green bowl, so I would have mounted it on the lathe, and this plate wouldn't be here. I was gonna focus more on the inside of the bowl with the electric lathe. But either way, I'm rubbing the bevel. And you zoom in, Jess. So it's the same thing as what I talked about before. Riding the bevel, depth, so the depth of cut has to do with me swinging the tool to the left or out. You can see I'm grabbing a little ledge there. So just what's engaged, the very tip, there's an angle, and that's the slice. That's the angle of cut that I talked about on the pole lathe hook. So we're going to get a nice slice on the surface. Trying not to push in on the tool. I'm trying to slide along the surface. It's a little bit easier to push with the electric lathe than it is on the pole lathe. And now I'm catching on the ledge, and it's a shear. So now I can turn the tool to adjust the shearing or the peeling.
some say that there's a kind of a magic, this 40-degree angle is kind of magic with wood. And it just peels really nicely. I'm not sure if that's true or not. I wouldn't know how to measure that, but. So I can adjust the shear by raising and lowering the tool a little bit, by twisting it. Again, what's most important though is where that slice is happening and what kind of finished surface are you getting off of the tool. If you turn too open, you know, now you're getting a 45-degree slice. The shear is nice too, but the surface might not be as sweet, as a little bit lower angle. And the beauty of the electric lathe is that it's fast compared to the pole lathe, but also the problems with that is you're having to design quite quickly. It's taking wood away really fast. So I tend to move the tool faster than I should, and that comes up with all kinds of problems. I definitely like designing rolls on pole lathes because it's so slow and you get to really consider what each cuts are doing. So just a little quick example of the inside. I mean, again, there's nothing different about these gouges than the hooks that I was using earlier, at least when it comes to what's going on with the edges. The nice part about this Harvey lathe is that the headstock spins out. So for hollowing, it's pretty sweet. So the same thing goes if you wanted to work the rim. You know, it's that same shearing cut. We're using the wing of the gouge. It's the same as the hook. And we're just shearing along. And then when we're hollowing, you should turn just to the left a little, so you're not in the line of fire. So again, it's hard to see because Jasmine should be on the other side of the lathe, which she's not going to be. But again, we're just slicing on that tip, just past the tip, and then we're shearing on this right side of the right wing. And then rubbing the bevel to control depth of cut and the curve. It's pretty straightforward. And again, the bowl gouges for hollowing, you know, I run different angles and these angles relate to the shape of the bowl so that the bevel is always rubbing. So the steeper, smaller the bowl, the would be the more 90 or more obtuse of the angle. And I think there's a limit. I don't know if it's 85 or 90. I'm still learning a lot about gouges. So you can run that in. I'm turning left-handed just to give Jasmine some space. It's the same thing though. You know, this wing is shearing or peeling, and then just the tip or just upside of it is where the slice is. And so by adjusting the angle, gives us the angle of slice, you know, gives us that smooth surface. And then how to peel, you know, raising up the tip a little bit, I think helps. But at the end, especially with electric lathes, the differential in speed, this is going quite faster than this, measured in feet per second. And so when you're pushing your tool feed, your speed at which you're pushing it through the wood, you want to slow it down quite a bit because the speeds are different. So I tend to really go slow at this point. And I'm always trying to find the sweet spot where the shearing and the slicing happens nicely. And this is where some advocates like Vila Sundqvist, he was interested in what he called the cutting technique instead of like just scraping, which is what these are doing. But he was using some hooks on the bottom of the bowl. When I first started with the electric lathe, I was doing that too, just because I knew pole lathe hooks. I knew how they were supposed to be. Tool rest is going to be up a little higher than normal. This hook is not set up for side grain turning, but I think I can make it work. But you're going to be approaching that. Approaching it the same way as the pole lathe, the same way as the bowl gouge too, but we have to be below center because we have to reverse engineer that sort of 20 degree. So that's where hooks are below center with an electric lathe. And just like the pole lathe, if you're going to use hooks on electric lathe, then you have to think about the pivot point. And you're only pivoting. You're not pushing or sliding or anything. So on slicing and shearing. You want to make a nice arc. Let's see what it looks like. So you're going to get way better finish on that bottom with a hook, because the slicing and depth of cut, they're just lower angles than that thicker bowl gouge. But it's also harder to get a pivot from your tool rest all the way from whatever point you want to start, from the rim all the way down. I can't even get it with one pivot. So I'd have to do it in two. So that's the trick with the hooks, with hollowing. I think gouges are way better. From my experience, side grain turning and gouges are where it's at for electric lathe. Pole lathe is hooks, of course. And then the Japanese lathe is really great for end grain only, not side grain, because the hooks don't work well with the power for what I was saying, that those pivots, same problem here as with the Japanese. So let's go to the Japanese lathe. Sorry, oh, there's a gouge I could have used. So this tool or machine is a little bit of it's basically electrified strap lathe. A strap lathe was, I wrote a blog about this if you're interested in like the differentiations between different lathe designs, technology. You have a shaft type lathe, and then you have the centers lathe. Forget what I called it. The shaft lathe is literally a drive shaft on some bearings, and that's being driven with either strap wrapped around it or electric motor. Electric motor only goes in one direction. The strap lathe went in both directions, like the pole lathe. Probably one of the original lathes, strap lathe. And they sat on the ground, and someone drove the main drive shaft, and the shaft had some spikes on it, and you'd hammer your wood onto it, and then you'd sit in front and turn. Because strap lathes have power both right and left hand, or forward and reverse, the techniques, and there was no real tool bed. It was just mounted on the ground, and the turner sat here while the assistant
was driving it, the style of cutting evolved to be able to use both forward and reverse as a powered cut. Unlike the pole lathe, where the downward cut has the power, the spring just returns it. It doesn't have enough power to actually make a cut, or not a very deep cut anyway. You can exploit the spring on a pole lathe a little bit for some kinds of cuts, but it's not the mainstay. So this lathe is a carryover, a modern version of a strap lathe. So is our Western lathe, actually. It's very different than would be the type where your workpiece is put between centers, and then the mandrel has to be attached, or in the case of like a pole lathe with legs for chairs, the workpiece is the drive. The drive mechanism gets wrapped around it. So the Western lathe and the Eastern lathe are similar that way. Pole lathe is a little bit different. But all that to say, the cutting techniques for this lathe developed because they could go forward and reverse. And then when they got motors, they kept all of that because the techniques had already evolved for that. And so they developed a flat belt system. This one doesn't have it. But in Yamanaka, there's these flat belt lathes that have both forward and reverse because one belt is twisted to a figure 8 and they're on idler bearings. And there's foot pedals that move the belt on and off the spindle to power the lathe. So they kept the same thing as the strap. They were able to turn forward for some cuts, some parts of the bowls or cups, and then turn in reverse for hollowing. And so that's why it is the way it is. It's still carried over to those techniques developed by the strap lathe. No tailstock, still sitting. Where I studied, there was a lot of production turning. This flute turning is a hobby in Japan. And so everything where I was jam chucks. It's just faster. So if you're going to turn, my teacher's 30 to 50 bowls a day, that jam chuck saves a lot of time cumulatively. Yeah, I'm just like squeaking this on and off. I just, doing that 30 times, I just wasted 3 or 4 bowls, which is money. So I later went to a different area, and my teacher there, Kawakami, he had put a 4-jaw chuck on his because everybody has VFDs now. So the Yamanaka lathe is quite special in that it has flat belts, even though there's a VFD controlling the motor. And Kawakami just put a VFD and a V belt direct to the spindle. And that was also because he was turning a wide range of products versus Yamanaka. It's a very limited number, so they can get away with cup chucks. They're not turning like all kinds of different things. He was turning plates, cups, and bowls, and small sake cups. So it's a little bit of the background. So again, it's the same thing. Now I won't cover side grain turning on this lathe. You have different hooks that are kind of built differently. And again, they don't cut the same as a bowl gouge because of the pivoting, the limits with pivoting, and thick hooks with thick obtuse edge geometry don't quite work the same without a nice tool rest like we have on electric Western lathes. This mobile tool rest moves too much with the resistance of like a bowl gouge. But also a gouge won't work because I can't push. I can't be out here pushing on this tool rest. So really it's limited to hooks. And I would say, even though they do turn side grain in Japan, it's pretty slow going compared to a Western lathe and gouges. A lot of people who are turning wider
bigger trays are had switched to Western style turning in Japan. But end grain, this tool really shines. So what we have now, you might want to come closer, Jess, just to show this. Is a hook that is not so different than a bowl hook for pole lathes. So still the cutting, the slicing is happening on this part, and then, well, I guess it depends on where we are, what we're talking about, but it's still, we treat it the same way. This apex point, where's the slice, where's the shear, or where's the peel, depending on what we're doing. And then they also use different scrapers that are burred and pull off really fine shavings. They're cutting too. It's peeling, but with a really fine edge.
So I'll just turn the outside of this. So the mobile tool rest is a lot like the pole lathe. And this is why I was attracted to this style turning. When I hurt myself turning handle cups, I saw videos of Japanese people using hooks, and I already knew how to use hooks. So the relationship of the distance from the bed to the table to the tool rest and the pivot point are integral with your height and the shape of your tool shearing, or this part of the hook. They're all interrelated. You can't just make it up. If you do make it up, then you have to make hooks to match what you have. If you change your tool rest, your hooks won't work. So then you have to make new tools or change. So I moved this lathe from home to the new shop, and I redesigned it because the other one was built a little too tall. So anyway, it's not just willy-nilly. So we're slicing along the surface in a pivot cut. Now, I could have a hook that has a more straight, I don't know what you would call that. I guess a tip, more straight instead of this acute angle. And then that would get more of a, what a skew chisel does on the surface of an end grain or spindle. It would make it nice and smooth. But right now it's just cutting just on the tip and a little bit, because this shape and this shape don't interrelate. So if you ever watch videos of Japanese turners, their hooks are designed to match the shapes they're making, and they're also doing production works, which makes it easier. If you're going to make 300 bowls of one shape, then you make a tool to make those bowls. Where I'm doing a variety of shapes and designs, so my tools aren't as effective because they're set up to be more versatile. But if I moved over a little bit, get a wider spreading and show you. So this style of hook works on electric lathe for end grain. Great. You just have to raise your tool rest, and you have to move your tool rest around. These things are very mobile because, you know, we're moving along quite quickly and we need to move the tool rest. So the mobile tool rest is directly related to the shape of the hook and how effective it is. If I had a hook that was set up for this form, I couldn't just pivot from over here, or I couldn't pivot from over here. The tool wouldn't work right. I have to move my tool rest along to make it. So the tool rest is integral into this geometry, which is really interesting. And then scrapers. We didn't deal with scrapers at all on the other electric lathe.
I don't usually use them, but for end grain I do, and I'll just show you a couple other trick tools and then we'll field last questions and call it a day. It is almost one, it's 2 hours. Man, I can talk. So this one below center is a really dangerous tool. And when I was in Japan, I was warned about it. It took me quite a while to figure it out. The burr isn't right, the edge angle isn't right. It'll pull the tool with a violent force because it's below center. Those are shavings, and then it's a smooth surface. I'm not going to do the whole cup. Yeah. And then last, they use these handheld scrapers made out of high-speed steel hacksaw blades. You can buy them on eBay. They're ground quite thin, and then there's a small bevel. And you have to adjust that edge angle, that burr angle for the types of wood you're using. And these are constantly, both scrapers are constantly being sharpened. Basically with every pass or two, I will maintain the burr because it just gets worn off so quickly. And they're just handheld. A little dull, but you can get a nice surface. Also, really good for, and then, you know. So one last bit, the hollowing.
Question.
Yep.
Do you always shift the rest between cuts, or can you cut while moving the rest?
Can't cut while moving the rest. It's just like the pole lathe, you're making pivot cuts. So it's not a very controlled cut because there's no bevel to ride. And we're on the outside of end grain, so it's all spindle work, it's all shearing. So there's not a lot of resistance in the cut itself to maintain stability to make the cut. So it's better to have the pivot point locked in and move it with each pivot. You know, you wouldn't have to take wide pivots. You could take small ones too, but the exception would be hollowing. I will slide the rest because I'm making these long cuts, and I'm going to demonstrate that soon. Who asked that?
Kalia.
So the I guess why this lathe works best for end grain is the tool rest is so mobile for the pivot cutting of hooks. It just works. Like when I rough turn, sometimes I'll rough turn on the electric lathe. I'll grab a hook, but the tool rest is so set up in such a way that it doesn't work effectively. I have to move it all the time. So you're better off like turning the outside of end grain on an electric lathe with gouges and skew chisels. And that's when I teach at Northhouse. I teach on electric lathes, end grain, and that's what we use. And then on the hollowing, we use hooks. And that works as well because you're just pulling the tool out. So your tool rest can be set. And you can just pull it out. It's the same thing as what I'm going to do here. If that makes sense. So now I'm going to go in reverse. I have this other little hook. This is a traditional shape from Japan too, very much the same as our hooks, as pole lathe turners. So.
Now granted, there was a hole already in this when I dried it. But you could, drill a hole with a handheld twist bit and then stick your hook in and hollow too. And that's how I teach it. So for smoothing, instead of using the Martel style hook, or the pole lathe version, this is the Martel hook. You can see it's set up for turning in forward, and it slices down. I guess what the difference is our pole lathe ones, I think the angle is a little bit more tighter. And then Martel's hook, it's set up to plunge on this part of the edge and then hollow and smooth on this. And this is trademarked. The reason why it's trademarked is as you roll this shaft, all of the edge is always touching no matter where you spin it. I've tried to duplicate this with a forging, and it's really hard to do. The edge is always engaged as I spin. It's trademarked or copyrighted. But you clamp this on the hollow rod, and I always thought that this got in the way on a pole lathe. Plus the edge geometry wasn't quite right. I'd have to tip it up quite a bit, and with a pole lathe, it didn't work. That's why I made the other one. But this is set up to go in and slice. It's just basically a skew chisel inside out. So I know hooks. So what I did was forge the hook with a stronger bevel, thicker material. This is M2 high-speed steel. Some point I'll be selling these. And from where my fingernail's touching down to the tip is an angle, which is the same skew that we need to slice those fibers. Just like Martel's, just like a skew chisel would be used on the outside of something. And then the bevel, of course, helps us to control the depth of cut. And you can use this on an electric lathe without the mobile tool rest. This one works with a little bit different height. So I have a different tool rest. And you're just sliding. It's the same cut, right? Slicing on that angle. And for depth of cut on this, you raise your tool rest to a different part of the circle, right? If you're cutting up here, the depth of cut is increased. And if you're cutting down here, your depth of cut is decreased. You can also turn your tool to make that depth of cut as well. So you're riding the bevel, but you can increase how it relates. If you bring this up, your bevel isn't engaged anymore. You're using your tool rest as a pivot to control and the leverage of the handle, but you're increasing your depth of cut, lowering your depth of cut, increasing your depth of cut. And then, of course, you can adjust up and down a little bit too, so that you can adjust the skew or the edge, the cutting angle. So, and then last is a crazy scraper that's designed to scrape the bottom of the cup and then come across the bottom. And then it's set up to skew, slice on an angle across the finish face of
What's an end grade cup?
You won't be able to see it because it's deep, but you come across. Slides up. And then last, I run some handheld scrapers down there too. Again, they all have burrs. Fine shavings. And then finish, finish the rim. End grain. So,
How do you refresh the burr of the crazy scrapers?
I use stones, and then at some point I'll take them to my regular flat sharpening stones to readjust, grind them flat again, and then put a new burr on, usually with a water stone or a diamond stone. This tool is now overused and it doesn't work the same. So either I gotta forge the head back or I have another one in the works. The edge geometry isn't quite right anymore. At one point it was like that long. And I just used the stone to do that. And it's really important to keep that burr, at 2000 grit. It makes the best shavings.
Final questions or?
Yeah, is there any other questions? Now's the time. I hope people enjoyed this, learned some things.
Maybe we can talk about our school a little bit.
Tool steel for your hooks. I use M2 for electric lathe hooks, which you can forge and heat. You could follow up with an email with the specifics, but that's kind of a rabbit hole. And then for pole lathe turning, I use 01, and I don't heat treat the 01. I do heat treat the M2. Yeah, so I don't know what you want me to say about the school. They already know.
This is for people who watch this in the future.
Online, yeah, I suppose we're gonna put this on YouTube after some months. You guys paid and you guys get to watch it and of course interact. So that's the whole point. Appreciate people signing up. We tried to keep it just low price, so it's kind of like a donation for the time. And if you have any questions, you can follow up via email. We have the YouTube channel with a bunch of other videos on turning on pole lathes mostly. It might be of interest. And yeah, for those that are following along, my book is written. I'm reshooting the photos at a snail's pace. Hopefully probably realistically by the end of the year. I don't want to keep making promises I can't keep, but I'll have all that done. And once it's in Lost Art Press's hands, who knows how long that'll take. So it's coming. Also, I'm teaching up at North House, end grain turning on electric lathes. And then I run classes here, private classes. If people want to come over and hang out for a couple of days and learn about hooks or turning, forging hooks, that's kind of where I'm heading. It's just small classes, more intimate, more in-depth. That's about it, I guess. For finishes, I'll just plug Hisui Ceramic because we're the only importer. If you don't know what it is, you can check it out on the website. It's a silicon polymer, inert, doesn't smell, doesn't taste. It's really good for finishes on woodenware that's going to be used for wood stuff. So check that out. Otherwise, get some comments here. Good camera talk, Jazz.
Thanks, Charles.
Some little screen popped up. Here we go. Yep. All right, folks. I know some of you personally, so it's nice to at least talk at you. It'd be better if you were all here. But until then, thanks, and hopefully we'll meet all of you down the road sometime. We'll see you later.